Okay, well, for people who are joining this live stream, we are doing a design review, design meeting about new features for Wolfram Language. Since we are about to release version 11.3, this is features for future versions. And we've got a list of things we're going to look at today. We'll probably go and get beyond these. So let's start off, subset cases. So what is this? This is a proposal to...
Yes, so we have Tony with us to talk about this. So this is not evaluatable. Mm-hmm. So I think the idea here is to generalize sequence cases to the case in which the objects of the sequence are separated. So it's...
Right.
Is that right, Tony?
Yes, they can be separated and in any order. These are the two constraints that we are releasing.
Well, so those constraints could be different constraints. Now, don't we have a thing with sequence analysis where we have least common subsequence, all these various, there's a whole family of functions around sequence alignment that allow for different kinds of, let's see, sequence alignment. I believe we have all these things about longest common subsequence, longest common sequence. Do you recall how that works? So those have to do with this question about whether, first of all, whether the things are, longest ordered sequence. There we go. Mm-hmm. In a list, perhaps disjoint. Okay, so this is looking for sequences that occur in order, so are essentially monotonic, but might be disjoint. And you're saying is, in your subsets thing, you're allowing them to be at any position, as opposed to simply be, right, an ordered sequence. Am I making sense?
Yes, I think Tony's point is the pattern, having a pattern rather than looking for ordered things.
No, I understand that, but this pattern could require that those things be in order. Right?
Yes.
No, the idea of this subset cases is that they don't have to be in order.
I understand that, but I'm asking you, you think it's useful? I mean, right now we have sequence cases which requires them to be contiguous and in order. As you say, subset cases allows them to be not contiguous and not in order.
I guess the question here is, in the same way that we have subsequences and then sequence cases, and we have subsets, and these subset cases, would we need a permutation cases or something like that?
Or do we care? I mean, it's not clear that we care. I mean, if we have subsequences, okay, so subsequences of like this would be those. Okay, fine. And so you're saying that is what sequence cases, goes. So if I say sequence cases, fine.
Mm-hmm. There are options to control overlapping and things like that.
Okay.
Mm-hmm.
Okay. So now, in the subsets case, you would imagine that I would get subsets. Does subsets have a second argument?
Yes, but I think you need a list if you want pairs.
Okay. So this is what you're arguing for, basically.
Yes.
And you have a reason to think that the ordered case is irrelevant?
Tony?
Yeah, I'm thinking of finding, for instance, subsets of links 2, where, I don't want to worry writing the first pattern Yeah.
No, I'm not asking whether subset cases as such is useful. I'm asking whether the ordered case, whether you have an argument for why the unordered case is definitively more useful than the ordered case.
If we don't care about the order, it would be more something like tuple cases.
Wait a minute, I'm sorry. Your thing here doesn't care about the order, right?
Correct, it doesn't care.
Right, so I'm asking, explain to me, so what is the use case for the thing you have here?
So I have a use case in an implementation where I have a list of expressions and I'm trying to find all pairs, for instance, that satisfy a certain pattern constraint.
Okay, why do you want that?
For instance, to implement a simple version of RDF reasoning, that is my application, where you can say, given that and that triple, add an additional triple. That means in a list of all triples, find certain pairs. That would be subsets of lengths too.
Okay. That have certain properties. And so why isn't this
Yes.
subset select? I mean, do we have...
Because in my case, I want to extract certain parts of that expression, and that is more convenient with cases like. I could do the same with select, but it would be more difficult.
But so, and we don't have a sequence select. Okay. Look, I think this seems reasonable. I mean, if you have an implementation, I think it's a clear function. What are the weird cases with variable length patterns and so on?
It becomes a little bit more complicated when you have a pattern test on the whole pattern, for instance. Mm-hmm. And the variable length patterns are complicated.
So what would you do in that case?
I don't have a good idea for an efficient algorithm that would work in all cases.
Okay, but functionality-wise, a double blank would pick its elements from any position in the list. Is that right?
Mm-hmm. So the most nice thing would just be to get all the subsets and then do cases on it.
Well, hopefully you can prune that tree a bit better than that.
Yes.
Okay. Look, I don't object to this function. Anybody else object to it?
I was thinking that when we introduce a cases function, we typically have an associated position function and count function. And actually, we do have a sequence position, sequence count.
Oh, boy. And what would subset position possibly do?
Find, good point.
I mean, sequence position presumably gives does it give the span or does it give, that wasn't very useful for this particular thing.
Yes, so it will give the list of positions of the respective elements.
I see. As opposed to, I mean, this particular thing is giving, right. So, yeah, right. So it can give, I see. So, yes, okay. I mean, it could do that. I agree. It can do that. Seems awfully overkill. Mm-hmm. Have we ever, have you ever needed this?
Not that I remember, but because cases, position, and count are so similar, we decided to go for the three of them.
No, I understand sequence position. That's perfectly reasonable. Well, let's get some preliminary implementations of the subset cases, subset positions, subset count. And if they really seem, I think, yeah, if they really don't seem sensible, we will make them into function Packlet, function repository things. Otherwise, I think that's fine.
Okay.
Unsorted intersection.
Yes, so this has appeared several times, which is versions and unsorted versions of intersection, union, and complement.
I know.
And this might be useful. It appears frequently.
I agree. What would we want to call them? Could we call them union unsorted, or are we going to call them, I mean, is that, would that be a reasonable thing to do? Do we have other functions that are...
Could have a sorted option for the existing functions.
No, we can't, they're varargs.
Bleh.
Well, we do have options in them, like semi-test.
Yes, I know. I don't like having a sorted option. I think that's kind of crazy. Graph union does something different, right? Yes, it does.
I don't think we have an unsorted function. We had the plan of an ordered association.
Right. Okay, but so in this case, if we, I mean, this is a function that we've had bubbling around for at least 20 years. Unsorted union, union unsorted.
Mm-hmm.
Just to be clear what it would do, we're talking about something where it is going to take the first instance of every element, and that will determine its position. Is that correct?
Yes.
And is there any variation on that we would want?
I
mean, these are literal elements, so there's not really, it's like, that's just determining the order in which the elements occur. Right? So if I say, you know, is any notion in which,
well, union and intersection are symmetric functions, but complement is not. So complement is the only one in which we might want to do something different, because the first list is adding elements, the other lists are subtracting elements.
Mm-hmm.
So I wonder whether that requires different treatment.
On our live stream, Michael Hale is pointing out he uses delete duplicates as an unsorted union, indeed.
Mm-hmm.
I mean, that's the one argument form of union.
One arg, yeah.
The question is what to do with, does raise the question of whether...
It has a second argument.
Yeah, okay. Right. And this has the rather ugly same test.
Yeah.
So what are you saying with respect to the complement case?
I was thinking that with complement, the order should be determined basically by the first list.
The universal set.
Definitely.
Right. Is there a better word than unsorted?
Mm-hmm. I was thinking about that here we have always this problem of, do we mean keeping the order or not caring about the order? So,
could call it something like list union, since list implies ordering, sort of.
No, but that would suggest that it might do something different with its varargs setup.
Really?
Well, I don't know. Could whoever has background conversation there put themselves on mute? Okay, so look, it's fairly clear what these functions do. Again, we've certainly heard about these things. What do you think about unsorted versus, union unsorted versus unsorted union, and what do we think? Is there any choice but okay, so SG Huisman is suggesting on our live stream a complement function that takes account of multiplicities. so you can subtract sets. Let's look at his example. I see. Kind of interesting as well. How would you do that otherwise? That's removing the elements of the subsequent sets from the first set.
This would be like supporting multisets for which we don't have functionality in general.
What will be another example of a piece of functionality for multisets?
It's like computing subsets with repetition.
Yes.
And or union with repetition, etc.
Well, what do you mean by union with repetition? What would union with repetition mean?
I guess we would have to set like maximum number of repetitions.
Oh, I see what you're saying. Right. I see. So keep accumulating the number of times that A appears. Yeah, keep accumulating A's until you've got at most 3 of them. Yes, there's a point on that live stream pointing out that you can get, no, I mean, join and sort would do what we're describing. If you allow an infinite maximum number of occurrences of the same thing, then you can do that. If you want to have a ceiling on the number of occurrences of something, then you would need something different. I mean, so this, for example, would obviously do that. And if you wanted, I mean, there are multiple different operations. So, I mean, the problem is here, okay. So, is it sorted? Is it ordered? Does it account for multiplicity? Does it have a maximum multiplicity? I mean, I understand in this complement case, once just subtracting, take away the 1, take away the 2, etc., take away elements that are in the second list, and you get left with a certain set here. I mean, isn't this a set minus type thing? Isn't that more what that is?
Could be. I mean, calling it set would suggest that we don't want repetitions, but yes, I think I see what you mean. We have this issue as well with subset. Actually, like for example, subsets of AAB, list 2 will subsets.
Oh, okay. Yep.
Here you see it will return AB twice. And this sort of thing has been, it's a problem sometimes. The fact that.
But it isn't, in fact, doing set theory subsets, so to speak.
Exactly, yeah.
Oh boy, this is a mess. I don't think this is. I don't think this is a problem we're going to solve today. The only one of these things that I agree one has wanted. Where does one need unsorted union? Seems to appear. I mean, there's a more general operation here, because what it really is it's like a fold operation, in which you are progressively, accumulating stuff, but dropping things that you've seen before. But you could imagine accumulating up to a certain multiplicity, and you could imagine a bunch of different variants of that.
For example, I use these functions when I'm working with indices in tensors, because you have to keep the order in which they appear. And you have multiple indices from different tensors. And
so why do you need, I don't understand why the unsorted union is the right thing there.
because you want to know which indices appear and you want to keep the order in which they appeared. You don't care about how many times they appear, but it's important to know in which order they do appear.
Right, which makes the name Unsorted Union pretty obscure.
Exactly. Sorted versus unsorted is always very complicated. This is some sort of union keep order or something like that.
Well, no, but I'm saying that what you're really saying is it's like delete duplicates, and you know, it's like some kind of multi-list version of, which is what it obviously is, of delete duplicates. You know, there's a certain argument. It is, you know, it's delete duplicates of join of the list.
Yeah.
I think this is kind of a mess, and I'm unconvinced about these things. I mean, but the one thing we can do, which is sort of a new path for us, is to put some of these things in the function repository, and you know, which requires less design review. That this Sander is on the live stream is suggesting, well, effectively list delete of some kind for this operation. I don't think it's quite delete. It's not quite delete, because delete is a positional. I mean, it's not even quite list delete cases. It's almost list delete list, because it's saying.
Yes, and it would be good to have a naming convention that keeps the parallelism with complement union intersection.
Sure. Yeah. All right. Look, I don't think we can solve this today. I think, you know, there's possible function repository things. Maybe it's called list union. I don't think that's a great name for it. Let's keep going.
This is a small suggestion from Arnaud.
Directory file list. Yeah, I agree that this is really ugly, having to do this. Really ugly. And why does it have an excuse to not be called names, given that the other one is called file names? I mean, why not call it directory file names and have it take a directory? Well, I don't think it's a list of all files under it. I think it has the same. You really want infinity there? I wouldn't have thought so by default. I think you just want a list of the files in a given directory. It's the analog of file names. I mean, it just has different defaults from the file names. Instead of having a star there, I see. There's sort of an issue there. I mean, it could take, yeah, because the issue is, if it's called file names, you would expect it. Ugh, what a mess. You know, you would expect it to take that same file pattern. Yeah, I mean, then the problem is, okay, look, clearly if I say file names star.nb, and this is the current directory. Okay, comments from people about the naming of this thing.
Can we say something like file names all comma dir?
I'm sorry?
Something, I mean, I don't know whether this is already taken. File names of all comma dir.
I see. I don't think that's already taken, but let's seems to just work. You know, that may be our node solution. I mean, I agree that this quote star thing is ugly. Do we document all in file names here?
I don't know.
That's kind of stupid and ugly. I think we should document all there. And
it's already there.
Where?
Detail section line 4, I think.
I'm looking. Oh, yeah, all can be used in place of star.
Okay.
Well, maybe we should promote that to the primary documentation for that.
Or at least update the examples that use star to use all.
It's hard to hear you.
Sorry, I was just saying, or update some of the examples to demonstrate it.
I agree. Sandra is pointing out that blank also works. Yeah, I think all is a nice thing to put there. I kind of think update the examples, perhaps promote this into the top level documentation here, and leave it at that.
Okay.
Okay, let's keep going here. We're going to look at have a bunch of suggestions here. I want to talk a little bit about this business about maybe this is not the right discussion, not the right group for this, but discussion about animated graphics and so on, and the possibility of having what amounts to a time axis in graphics. So, this is something I've long been thinking about. It's essentially a timed, one version of this would be a timed plot where you could say, plot x plus t, let's say sine of x plus t, and then it's, x 0 to 10 or something, and then this t variable is, well, actually, I think it would be like this. I'm sorry, it would be like this, where you have both a position and a time variable. Am I making sense? Now, there's a question of the constant proportionality between seconds and, for example, I mean, how does that, we've got some analog of that. So, for example, in animate, we have got, how does this work? What is the correspondence between the time, actual time? I think it's this animation rate. That determines the, okay, people's comments on this timed plot idea.
So this would return something similar to manipulate?
Yes. But, well, I think the main objective here is to be able to write, the main place it gets interesting is when you have graphics and when you have, and again, this is not properly thought through, and maybe this is the wrong group for this. I think maybe we should have a separate discussion specifically about this. I mean, this is basically, this is related to the whole object graphics business and so on. All right, let's take a look now at my general list here. Vertex texture coordinates. This is a thing where, again, this may be the wrong group for this. I think this is the wrong group. We don't have Brett here, do we, today?
No, we don't.
Okay.
So what's the objective here? To do something automatically?
Yeah, the main point is that there are several options like fill, fit, stretch, these kinds of things are all different possibilities for what you want, texture mapping to do.
Yeah, we do that in geographics because in geographics we use textures a lot. And in fact, we are internally doing automatic computation of vertex texture coordinates.
I see. Okay,
Yes.
well then, so again, this, fill, fit, stretch, etc., are among the possibilities for what you want to have happen. I think in this version we got something. What did we get in this version? We got automatic. Okay. Come on, what on earth happened to this? Come on, what is that? Can we fix that, please?
Yeah.
It's a bit embarrassing. Let me find out why DQA did not catch that. Okay, anyway, wrong group. let's get that on a list for graphics review along with this one here. Okay, Sushma.
Okay. Yes.
Okay. Whatever happened to array association, otherwise known as apply keys and so on? Did that already get? Did we already move that to implementation?
Not yet. That's on my plate. I have been discussing with Xavier about it and the relation with dataset, but no, we don't yet have an implementation.
Okay. All right. Next on my list is stuff to do with the chat system. I don't think that's for this group either.
Yes, but they are also working on it, and they will bring that back to discussion.
Great. Find character encoding. Do you know the status of that?
That is something I need to ping Gihe, and she was working on it initially, and I think now she's focusing on tech import.
Okay, but how about she doesn't drop that?
Yeah, I will make sure that she doesn't.
Okay, so we also, another thing we had on the list is session information or session data. That is some kind of data set or association of detailed information about a session.
Yes, we need to basically design it more so that we have someone to work on it.
Okay. All right. We have the column map, column delete business, which I hope you guys are working on. Yes.
Yes, I'm looking into that.
Okay. Whatever happened to flattened?
Well, I have been discussing that with Itai. The idea is, I think it's doable. He has more concerns. Okay. Of course, it's. Sorry, I don't remember right now. So it would be better to have that conversation with Itai. He has some concerns about it.
Okay. So Sushma, can you get that put together?
Yep.
Okay. Oh yeah, there was a discussion about memory. This whole memory available business.
We do have yes, exactly.
Right. So the question is, for example, in the cloud, where there's user memory allocation limits, how does this work?
I see.
I think that's unknown at this point. All right, whatever happened, my next list thing here is line through, circle through, and so on. What's happened to those?
We have this, yeah.
No, I meant to say that last time we stopped at that and we wanted to discuss this again. But yeah, we can discuss it right now too.
Okay. I have next on my list after this is GeoListPlot3D.
Yes, that's also for me. So I'm right now developing the language of datums for elevation, which is going to be important here. And it's also...
Ultimately, this is going to put things on a sphere, yes? I mean, if I say just generically GeoListPlot3D of GeoRanges all, that's just going to give the whole world, isn't it?
Well, the sphere should be considered like a particular projection here. In general, we may want to have, how would I say, the XY plane being in some projection, and then the Z axis being elevation. Right? And so we need to add the possibility of saying the projection is the sphere itself. You see what I mean?
Well, actually, I got distracted looking at live stream stuff. Michael Hale is just strongly supporting column map. Yeah, we all agree. It's been not there for too long. Okay, sorry. Back to GeoListPlot3D. So what are you saying? You're saying that the goal is to project the data onto a sphere in the case of GeoListPlot3D, or what?
No. Well, what I'm saying is that that should be one possibility. In many other cases, one will not want a curved result. One will want, say, for example, imagine you want a GeoListPlot3D of the relief of the US. So we might want to to have some sort of base, which is a projection of the US, and then vertically the elevations. And so this function needs to take a geoprojection option. And then one of the possibilities, I'm using right now globe, but we have to name it, could be a projection which is a 3D sphere itself.
I see. So the question is, it's sort of what you're doing is, it is there are two different questions. One is that you're getting height information, and the other is that you are presenting like positions of cities on a sphere.
Right.
Or, for example, you're presenting things like satellite positions relative to a sphere.
Well, what I would say is that in the same way that we can have the map of the US in multiple projections, we can have also a 3D relief of the US in those respective projections with a flat base. And then,
yes, I understand. You can distort the looking from above, you can distort the shape of such and such a mountain.
Right.
You can distort the base, even though the height is, but I mean, for example, the question is the vector that goes from the base to the top of the mountain, is it a vertical vector, or is it a vector that's pointing, like a head, like some kind of, explosion from the center, radial vector?
Right. So we need both possibilities. So my plan was to have geoprojection goes to, say, globe or something, or sphere or ellipsoid. And then the base of the US will be curved, corresponding to the curvature of the Earth.
Yeah, but in the case of geographics, geoprojection aerosphere would do what?
Well, we could have it, I wasn't planning to do anything there, but it could simply put the map on the sphere. It's a flat map on the sphere.
Yeah, but then is it going to make a 3D graphic or a 2D graphic?
It's a 3D, but that's why it doesn't sound correct.
Yeah, I don't think it's correct there. Fair enough. But then I'm still a little bit confused here, and I'm not sure it's a single function.
Yeah, it's probable that we need a geographics 3D, and then again a series of visualization functions that call geographics 3D.
Yeah, but what do you think the real use case is for this? You think it's to show elevation data, in which case we're going to have a scaling function that determines, because otherwise, I mean, the Earth is extremely flat in some, or is this primarily to actually show a picture? I mean, like, in Wolfram Alpha, obviously we have, okay, let's just be clear what we're talking about here. I mean, we're, I don't know, let's say, something like this. If we do that, we should get, why doesn't that show us I thought that showed us a on the globe plot. Doesn't, huh. What's an example of something that does? I guess if we ask for, if we ask for something like this, I think we will get, okay, show 3D. I'm surprised that other one doesn't allow the possibility of showing 3D. It's not a very exciting 3D picture, but there's the 3D version of that. So that's what I was imagining we would be talking about. For many of these 3D things, is actually showing the sphere like this as a 3D graphic.
Yes. But I can imagine as well that we could have some sort of equirectangular base in which then we put the...
Yeah, I understand. The elevation data.
The elevation.
Or for example, we put the airplane trajectory flying overhead.
Exactly. Yeah, because sometimes it may be, I don't know, for a 3D printing object, you want to have an exactly flat base. So.
Sure, and we also might want, if we're showing this is where these two planes, you know, flew across the US or something, and they got, I don't know what, but yeah, okay, fair enough. I understand. I'm a little skeptical that it's one function. I mean, I'm kind of suspecting that there are different options that you need when the whole thing is going to be on a sphere than when it's on a flat base. Because, for example, yeah, okay, all right, to be continued on that one. Let's see, I'm looking at, how is the around business coming along for numbers with uncertainty?
Yeah, that's progressing, and yeah, it should be ready for the next version.
Okay. What happened to integer fractional part? Is that being done?
That's a very low priority thing.
Okay.
I mean, we can do it, but we haven't done it yet.
Whatever happened to bitwise function? Bit function.
I don't even remember that.
Yeah, I don't think so. We really discussed this in any early meeting.
I don't remember this.
Okay, so the idea of this is just like we have bitwise, you know, bit XOR. Okay. So also, I mean, to be honest, this is a fine function repository thing, if nothing else. You understand what it's doing. It's doing the analog of bit XOR, but this is, in this case, this is like a Boolean function, right? That's like Boolean function. What that's doing is it's doing the bitwise Boolean function of, so let's take it explicitly. That's like 150,3, and that is, if we say ABC here, that will be, if we say Boolean minimize of that, okay, that's XOR, right? That's the, I'm sure if I minimize that with respect to XOR, it will show us what it is. It's not good.
I think convert maybe, not minimize.
I think I just did, maybe I have to do converts here. Whatever. Oh, okay. Yeah, there we go. So that thing is XOR. Okay. So the point is, the point is, this is a pretty minor thing, but the point is just to be able to take a function of bits and be able to apply it. It's sort of a you know, it's a bitwise map.
Yeah.
I mean, you know, there's a whole bunch of functions around byte arrays that we really should have. I mean, this is essentially, yeah, I mean, we could consider this bitwise map. Well, it's actually bitwise map thread, unfortunately. And it's not obvious that this is the right way to do it. But that could be that one wants a Boolean function in there.
A reason to have supported the bit XOR, bit OR, et cetera, to begin with was the desire to attain huge efficiency. And we can do that because they all map to C functions. Doesn't happen in this general case. So I don't know that there's much advantage.
Yes, it does, doesn't it? I mean, it's the fact that those things are machine instructions.
Yeah. Or
I mean, you can implement, because we've, at least for Boolean functions, we can turn those into a collection of machine instructions.
I don't see how.
Shown on this
because we're
in other words,
well, in the way I just did it, right? You can always do it with DNF and CNF, and then you still get the factor of 64 speed up because you're able to do it in parallel across all the bits in the word.
I can show you.
I'm completely unconvinced about that, but
Definitely. That's how we do the cellular automaton function, for example. We should be wrapping this meeting. We have a suggestion from Sandra on our live stream about bin lists by, which is an interesting function. Let me think about this for a second. Am I going to be able to click on this, and is it going to just show us a community post? Is it in here? Bin lists by, it's there. Okay.
Mm-hmm.
So this is the determining function that determines what will put things in the same bin, right? That's the idea here. So bin lists on its own, how does it do that? I see.
Do we have a histogram by?
No, but that's not the same thing because what? No, we don't. But I mean, that's not the same thing. The point here, this is more like gather by. How does this relate to gather by? Okay, so Sandra is pointing out you can bin m-dimensional data in n dimensions. Well, it seems interesting, and perhaps we can look at this, and I think we have to continue another time. Not our most, okay, gather by does not give one the empty bins, is the complaint. Well, maybe that's a problem with gather by. Maybe gather by needs an option that's like the null records option for, you know, in the case of string matching, right? So that is an interesting question, whether, no, but that doesn't work because that's a different, I'm not sure I understand how bin lists by determines what the set of possible bins is. Okay, I think today has not been our most productive one of these meetings, but I think we are out of time right now, and to be continued next time.
Okay.
All right. See you all.
Bye.
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 Bye.